Hello and welcome for a new uniTFT-Designer video tutorial. My name is Michael and I'm working for Electronic Assembly's development team.
Today's tutorial is designed to give an overview of the possibilities for ifs and else statements in the uniTFT series. 6 different options are presented in this tutorial. The macro script language of the uniTFT series is compared to C code. First, I would like to start with a simple if statement. I would like to start with discussing the equivalent C code. If the variable R1 is less than 10, the command in the next line, command 1, should be executed. Optionally, further command lines can follow. They are executed independently of the if statement. On the left side, we can still see the C code. On the right side is a flowchart with the commands of the uniTFT series. In the following, we want to discuss the flowchart. We assume that R1 has a value 7. In our case, only one command is to be executed within the if statement. For this purpose, the uniTFT offers the possibility to skip lines. In our case, 1. For this, you need the command mfs, macro file skip. The command requires as parameters the condition for the jump and the number of lines you want to skip. Blank lines and comment lines are not counted. We want to execute command 1 only if register value R1 is less than 10. We must therefore skip a line if the value is greater or equal to 10. In our case, the condition R1 is greater or equal to 10 is not fulfilled because the value is 7. We therefore execute command 1. If the condition were true, the program would jump directly to the next command. In our example, regardless of whether the condition is true or not, the command 2 is executed afterwards. Other commands can also follow at this point. It would also be possible to execute several lines of code within the if statement. In this case, several lines would have to be skipped. However, this can easily become confusing. For this case, other possibilities of the if statement are better qualified. These will be discussed in the following. This shows a direct comparison of the C code and macro language. It is important that you skip lines with the mfs command. Therefore, the condition of the if statement must be inverted. Now, I would like to show an example of such a statement in the uniTFT-Designer. In this example, the state of the round icon button should change from unpressed to pressed when the value of register R1 is less than 10. For this purpose, the icon button was defined as a switch. The verification should be done when the button check register R1 is clicked. A macro with the name check register has already been created and linked to the button's press event. Now, we want to program the if statement in the macro. We use the mfs command as just discussed. To change the state of the switch, there is a command tcs. At the end of the macro, I want to show something in the terminal to demonstrate that this command is always applied. Let's have a look to the result in the simulator. Here you can change the register values at any time. First, we set the register value R1 to 20. The if statement is therefore not fulfilled and the state of the button must not change. However, the text AND is still output in the terminal. But if we change the value to 7, the state of the button changes. For simple if statements, skipping lines is a good option. However, if the case analysis becomes more complex or if several lines of code are required within the statements, this approach is not suitable. In the next example, I will discuss an if-else statement. We start again with the C code. If the variable R1 is less than 10, the function macro1 is called. Otherwise, the function macro2. Any number of lines of code can be executed within the functions. In our example, 2. Again, let's first discuss this example using a flowchart. The register R1 has a value 7. In our example, we have two states. For such cases, the uniTFT series offers the possibility to run macros conditionally. For this purpose, the command mrc, macro run conditionally, is used. As in the previous example, this command needs the condition for the case analysis first. The other two parameters are the macro to be called depending on the case analysis. If the condition is true, the first, in our case macro 1, otherwise the second macro is called. The register value R1 is 7, thus the condition that R1 must be less than 10 is fulfilled. In C code, the function macro1 is called. In the script language, the macro macro1. All commands within the macro are now executed. After running macro1, the command 5 is executed. This happens regardless whether the condition was fulfilled or not. In the next example, we will learn about an if-else statement where set is not the case. In the scripting language, this approach is very simple and suitable, especially when several commands should be executed within the instructions. However, it is only suitable for if-else statements. If you want to realize several case analysis within an if-else statement, you have to use other options, which will be discussed later. Let's take a closer look to the if-else statement in an example. For this, we use the same as before. The state of the icon button should change again depending on the value of register R1. But now, we also want to have the possibility to reset the button if the condition is no longer fulfilled. We use the command mrc. If the condition R1 is less than 10, we want to execute the macro blue button, otherwise the macro gray button. I also use a command for the output to the terminal in this example. I have already created both macros. In the macro blue button, the command tcs sets the state of the button to pressed. In the macro gray button, to unpressed. Let's start the simulator again. We first set the value of the register to 20. The condition is not fulfilled and the button remains gray. However, if you change the register value back to 7, the color of the button changes in the same way as before. It is new that the state now also changes if I reset the register value back to 20. In each of the cases, AND was written to the terminal. This will change in the next example. We have dealt with if and if-else statements so far. The next two routines treat if-else statements. The difference between both is the ending. In the first case, no further commands can be executed at the end. If the variable R1 is less than 10, the function macro1 is called, and the current function will be left. If the variable is smaller than 20, the function macro2 is executed and the function is also left. Only if no condition is fulfilled, the command 5 is executed. Using a flowchart, I will illustrate the procedure in the macro script language again. The register R1 has now the value 14. Now we have more than two different states in our case analysis. The uniTFT series offers the possibility to terminate the current macro and optionally call another macro. For this, we use the command mfe, macro file exit. The first parameter of the command is a condition under which the current macro should be terminated. In our case, we want to check whether the register value R1 is less than 10. This is followed by the macro to be started if the condition is fulfilled. In our case, the condition is not met because the value of the register is 14. The current macro is not terminated and the next command is executed. For the second condition, R1 less than 20, we use the same command, mfe. If it is fulfilled, we call macro2 and terminate the current macro. The register value R1 is smaller than 20, and the condition is therefore fulfilled. Therefore, macro2 is now called, and all included commands are proceeded. In this case, the command 5, which is at the end of the macro file, will not be executed anymore. The if-else-if statement is very clear and easy to understand. Depending on which condition is fulfilled, a different macro is called, and all following commands within the current macro are ignored. All commands after the mfe statements can also be considered as else branch. Now, let's apply the if-else-if-else statement in an example. We want to realize a traffic light. For this, I have added 2 more icon buttons to our example project and changed the color for the pressed states of the buttons to red, yellow, and green. In addition, I wrote 3 more macros to change the states of the buttons for the 3 different cases. In the macro red, the state of the corresponding button is set to pressed, and the other 2 buttons are set to unpressed. We do the same for the colors yellow and green. Now we can program the if-else-if-else statement. We want to leave the macro check register and call the macro green if the register value is less than 10. In case it is less than 20, we call the macro yellow. Only if no of the 2 conditions are fulfilled, the remaining macro instructions will be executed. In this case, we want to start the macro red and make an output in the terminal. Let's have a look to the result in the simulator. The register value R1 is set to 0. The first condition is fulfilled and the traffic light shows green. If the register value is set to 14, the traffic light switches to yellow. As expected, in both cases, nothing was output on the terminal. Only if the register value becomes larger than 20, an output appears in the terminal and the traffic light switches to red. We have just learned one possibility of if-else-if-else statements in the script language. In this variant, the current macro was always terminated when the condition was fulfilled. In the next variant, this is no longer the case. Again, we choose the 2 limits 10 and 20 as conditions for the statements. Again, we first look to the flowchart. We assume that the register value R1 is 14. In this method, we use the possibility to jump within macros. The necessary command is mfj, macro file jump. As all previous commands for the if statements, the command expects the condition first. We want that the following commands are executed only if the register value R1 is less than 10. Therefore, we must skip the next commands if the value is greater or equal to 10. The second parameter specifies the jump marker. A maximum of 100 markers can be set. A marker can also occur several times in the macro. In our case, the jump condition is fulfilled because the register value is greater than 10. We therefore jump to marker 1. Next, we want to check if the register value is less than 20. Again, we use the jump command mfj. We have to skip the next lines up to jump marker 2 if the value of the register is greater or equal to 20. This time, the jump condition is not fulfilled. We therefore execute all the following command lines. However, we cannot perform all commands to the end of the macro, because the commands of the else branch still follow as well. We must therefore jump after the commands we want to execute. For this purpose, we also use the jump command mfj with the condition 1, which is always true, and we jump to marker 3. At the end of the macro, further commands can be proceeded. In our case, command 7 is called. Compared to the previous variant, this one is more complex and is suitable when only a few lines of code need to be proceeded within the fulfilled conditions. Otherwise, this method becomes confusing. You can already see this in the comparison of C code and the macro script language. It is important to mention that in this variant, the conditions between C code and script language must be inverted. In the general overview of the script language, you can see very clearly the interaction of the jump command mfj and its corresponding jump marker mfm. Again, we use a traffic light as an example for this solution of the if statement. The 3 icon buttons and the red, yellow and green macros remain unchanged. We only have to adjust the macro check register. For the switching of the traffic light, we use 10 and 20 again as threshold values. Below 10, the traffic light should show green, between 10 and 20 yellow, and above red. We first check the case if the value is less than 10. So we have to skip the next lines if the register is greater or equal to 10. We use the mfj command and specify the marker ID 1 as jump target. If the jump condition is not fulfilled, the next lines are executed. The traffic light should show green and therefore we execute the green macro. We can now skip all further command lines that have to do with the if statement. We use the jump command with condition 1. This is always fulfilled, and we jump to marker 3, which we will place at the end. Now we set our first jump marker with the command mfm. We jump to this point if the jump condition R1 is greater or equal to 10 is fulfilled. For our second condition R1 smaller than 20, we use the same way as before. If neither of the first 2 conditions are fulfilled, we call the macro red at the end. Finally, we set the entry marker 3. In this example, I would also like to display text in the terminal at the end of the macro. Now we can start the simulator again. We see that depending on the register value, the traffic light behaves in the same way as in the previous example. The difference lies only in the fact that with each query, text is written into the terminal. The macro script language also provides the possibility to perform an if statement within a calculation. In a short example, I would like to set one variable in dependence to another. If the variable R1 is less than 10, the variable R2 is set to 1, otherwise to 2. The flowchart is quite clear in this example. We assume the register value R1 is 7. With the command VRI, it is possible to write to a register, in our case register 2. The second parameter of the command is a new register value, in our case a calculation. We use a calculation ifte. This itself requires 3 comma-separated parameters. The first is a condition. We want to check whether the register value R1 is less than 10. If the condition is fulfilled, the value of the calculation is a second parameter. Otherwise, it is a third. In our case, the condition is true. The value of register R2 is therefore set to 1. More commands can follow. Compared to the if statements presented so far, the ifte calculation is a simplification. It will be used mainly in the area of variables, for example, to set them to a value. As in the first and second example, I want to set the state of the button depending on the register value. We use a predefined macro check register. This is already linked to the button's press events. Since the calculation ifte returns a value, we can use the command tcs to change the state of the button. If the register value R1 is less than 10, the button shall be gray and unpressed. If the value is greater or equal to 10, it should turn to blue. The command tcs expects as first parameters the state of the button, 1 for unpressed and 2 for pressed. We can directly use the calculation ifte here. If the condition R1 is less than 10 is fulfilled, we have to return 1, otherwise 2. Let's take a look to the result in the simulator. As expected, the button remains gray when the value of the register is 0. Only with larger values, it changes the state to blue. If the register value falls below the thresholds, the button is gray again. The conditions within the if statement can also be connected with logical operators like AND, or not. In the last example, I would like to deal with the case whether the value of the variable is within two limits. We want to check whether the variable R1 is greater or equal to 10 and at the same time less or equal to 60. If this is the case, the function macro1 should be called, otherwise the function macro2. With the help of the logical operators, we can already realize this with the possibilities presented so far. The uniTFT series offers similar to the ifte instruction also for this calculation. We assume that the register value R1 is 42. As a result, the insideE statement returns true or false, depending on whether the value is inside or outside the two boundaries. Depending on the return value, different macros should be called. The previously introduced command mrc macro run conditionally is suitable for this purpose. For the condition, we choose the calculation insideE. This also needs 3 parameters. First, the register value to be checked, and second, the two limit values. In our case, 20 and 60. 2 calculations are provided, insideE and insideU. If the two boundaries should be included, choose insideE, E as equal, otherwise insideU. The register value is greater than 20, as well as less than 60. The condition is fulfilled. Therefore, macro1 is executed. After running macro1, the command 5 is executed. This happens regardless whether the condition was fulfilled or not. Similar to the ifte calculation, the inside function can also serve the simplification. It can be easily used in any of the presented if statements. A combination with ifte is also possible. I would also like to take a closer look at this function with the help of an example. The check register R1 button has been replaced by a bar graph. It provides values between 0 and 100. On the right side, an auto text was placed. This shows the current bar graph value. The macro check register is linked to the track event of the bar graph. The two macros for changing the button state, blue button and gray button, are already created. The check register macro is called each time the bar graph is changed. Depending on the value, the blue button or gray button macro must be executed. For this purpose, we use the command mrc, macro run conditionally. For the condition, we use the calculation insideE. With the help of the function object instrument value, we get the current bar graph value. For the two limits, we take the same as in the flowchart, 20 and 60. If the value is inside, the condition is fulfilled and we want to execute the macro blue button, otherwise the macro gray button. Finally, let's take a look to the result in the simulator. First, the button is gray. Only when the value of the bar graph exceeds the threshold of 20, the color changes. If the value is above 60, it will be gray again. We have decided to include the limits in the calculation. The button is therefore blue when the value is 20 or 60. We have learned several ways to implement if statements within macro scripting language. There are more various than in the programming language C. Depending on the use case, you have to decide which possibility is the most suitable for the particular application.
I hope you enjoyed today's uniTFT video tutorial. Maybe you have time and play around a little bit with our sample projects and enjoy our other tutorials.